Hi guys, today we'll be talking about calculating dlat or the difference in the latitude, Dlong or the difference in longitude, and departure along a parallel of latitude, which is also called as parallel sailing. So let's start with dlat first. Dlat is the difference in latitude between vessel's latitude of departure and latitude of destination. The rule of thumb for calculating dlat is if it's same names, if the latitudes are of the same names, the latitude of departure and latitude of destination, such as if it's north and north or south and south, then you should subtract the two values. If they are of different names, that is vessel's latitude of departure is different from vessel's latitude of destination, that is if one is in north hemisphere and the other one is in southern hemisphere, or if one is in southern hemisphere and the other one is in the northern hemisphere, then you will add the two values. Irrespective, in both cases, the dlat takes the name of the direction in which the vessel is traveling, in both the cases. So let's take examples for better understanding. So in example 1, as you can see, the vessel is traveling from a latitude of 30 degrees 10 minutes north to a latitude of 10 degrees and 25 minutes north. So the vessel, as you can see, is traveling in a southerly direction. So if we need to calculate the dlat between 30 degrees and 10 minutes north and 10 degrees and 25 minutes north, you can see they are both in the northern hemisphere, and as per the rule of thumb, if they are of the same names, then you will subtract them. So here we subtract it. You can put these values in the calculator as they are written. You can put 30 degrees 10 minutes north minus 10 degrees 25 minutes. You don't put north or south in the calculator, of course. And the answer that you will get is 19 degrees and 45 minutes. Of course, you name it south because the vessel is traveling in a southerly direction, as you can see from the diagram above. A similar example, if the vessel was transiting from 10 degrees 25 minutes north and going towards 30 degrees and 10 minutes north, in this case you can see the vessel is traveling in a northerly direction. So if we need to calculate the dlat between 10 degrees 25 minutes north and 30 degrees and 10 minutes north, in this case you can see that both of them are in the northern hemisphere. So if both of them are in the northern hemisphere, you will use the rule of same names, subtract again. So although the vessel is traveling from 10 degrees north to 30 degrees north, you still use the bigger number and subtract the smaller number from it. That's how you put it in the calculator. But in this case, of course, although the answer is the same as above, 19 degrees and 45 minutes, the dlat would be named north because you can see the vessel is traveling in a northerly direction. Let's take another example, this time of the southern hemisphere. So if in this case, in example number 3, you can see the vessel is traveling from 10 degrees and 25 minutes south and going towards 30 degrees and 10 minutes south. So the vessel is traveling in what direction? Southerly. That's right, it's traveling in a southerly direction. So if we use the rules above, if both the vessel's latitude of departure or latitude of arrival are in the same hemispheres, such as in this case they are the southern hemispheres, what will you do? Yes, you will subtract it. Although the vessel is traveling from 10 degrees to 30 degrees, you can still put the bigger number in the calculator first and then the smaller number. The answer that you will get is of course 19 degrees and 45 minutes, and you name it south because the vessel is traveling in a southerly direction. If on the other hand the vessel was traveling from 30 degrees 10 minutes south to 10 degrees and 25 minutes south, you can see the vessel is traveling in a northerly direction. You will again use the same rule, such as same names, subtract. You can subtract the smaller number from the bigger number in the calculator. The answer that you will get is 19 degrees and 45 minutes, but this time you name it north because, correct, the vessel is traveling in a northerly direction. And finally, the last example, if the vessel was traveling from 30 degrees and 10 minutes south to 10 degrees and 25 minutes north, in this case the latitudes are in different hemispheres. So one is in the southern hemisphere, the other one is in the northern hemisphere. Different names, you will add it as per the rule of thumb. The answer, of course, you get is 40 degrees and 35 minutes, and it's in a northerly direction, so you name it north. So this is how you calculate DLAT. Go through the different examples again to get a better understanding. Now, how do you calculate Dlong, or the difference in the longitude? To do so, the rules are very similar to that of DLAT. The rules are again same names, that is, if they are east and east, the longitude of departure and longitude of arrival, or if the longitude of arrival and departure are in both are in the western longitudes, then you will subtract the two longitudes and you will name it in the direction of the travel. Similarly, if the longitude of arrival and departure are in different longitudes, such as one is in east and the other one is in west, or vice versa, if one is in west and the other one is in east, you will add the two values and again you will name it in the direction of travel. Let's take the example here. So here the vessel is traveling, as you can see, from 110 degrees 15 minutes east and going to 135 degrees 20 minutes east. So if you think about it, you're facing the directions, your north and south, and east and west would be how I have drawn it here. So as you can see, the vessel is traveling in a easterly direction. So since both the longitudes, that is the longitude of departure and arrival, are in the same longitudes, east longitude, you will use the rule same names subtract. Although the vessel is traveling from a smaller longitude of 110 degrees and 15 minutes to a bigger longitude of 135 degrees 20 minutes, because you will be subtracting the two values, you can always take the bigger value first and then put in the smaller value in the calculator. The answer that you will get is 025 degrees 5 minutes, and you will name the Dlong east because the vessel is traveling in a easterly direction. Of course, if I was to reverse it, and if I would to say that the vessel was traveling from 135 degrees 20 minutes east to 1110 degrees 15 minutes east, you can see the vessel is traveling now in a westerly direction. So coming to this example here, you would do the same as you did above. You would take the smaller number and subtract it from the bigger number. The answer that you will get is again 025 degrees and 5 minutes, but this time you will name the Dlong west because the vessel would now be traveling in a westerly fashion. Similarly, now if I use the western longitudes, if the vessel was traveling from 070 degrees west to 090 degrees west, the Dlong would be 070 and 090. You subtract the smaller from the bigger number, the answer would be 020 degrees, and you will name it west because the vessel is now traveling in a westerly direction. If I reverse it, of course, if the vessel was to travel from 090 degrees to 070 degrees, you would again subtract the smaller number from the bigger number. The value that you will get is 020 degrees, but you will name the Dlong east because now the vessel is traveling in a easterly direction. So that's how simple it is. However, there is one part which is a bit tricky in calculating Dlong. Let's go through that. Now the tricky part comes when the longitudes are near the anti-meridian, which is also called as 180 degrees east or west. So the anti-meridian is on the opposite side of the 000 meridian, or which is also called the prime meridian. So if you look above, and if I can take you above, you can see here I was talking in reference to the 000 degrees meridian, which is also called the prime meridian. Now if you imagine the surface of the earth as a sphere, you know that on the other side of the 000 degrees meridian is of course what you call is the anti-meridian, which is the 180 degrees meridian. In this case now you can see that the west and the east reverses. Ordinarily the eastern side is depicted as the right side and the western side is depicted at the left side, but when it comes close to the anti-meridian, it reverses. So if the vessel was traveling from 170 degrees east and traveling towards 160 degrees west, you can see that although it's traveling from an eastern longitude to a western longitude, the direction of travel, if you can again imagine the direction of travel like the way I've drawn it, in this case is easterly. So the Dlong between 170 degrees east to 160 degrees west can be calculated as follows. Because they are different names, you can use a rule of thumb and add it. The answer that you will get is 330 degrees 00 minutes west, but longitudes cannot be greater than 180. Cannot be that. So what you do is, once you get a value which is greater than 180, you subtract it from 360 degrees. The answer that you get in this case will be, of course, 360 minus 330 is 030 degrees 00 minutes east. But why did you get east here? It's because you will reverse it once you subtract it from 360. As you can see, this matches the direction in which the vessel is traveling. So let me repeat that although the vessel was traveling from 170 degrees east to 160 degrees west, you added the two. You initially named it west because that's what you would do if the vessel was traveling from east to west. But because the longitude cannot be greater than 180 degrees, you subtract it from 360 degrees. Forget about the negative sign. You put the bigger number first and then subtract the smaller number from it. So you put 360 degrees in the calculator first and then put 330 degrees. The answer that you get is, of course, 030 degrees 00 minutes. But this time you reverse the direction as well, because conceptually that's what the vessel is doing. And of course, if I reverse it, if I reverse the direction of the vessel's travel, so if I was traveling from 160 degrees west and I was traveling to 170 degrees east, similarly, although they are different names, you will add it. The answer that you get is 330 degrees 00 minutes east, because you feel that you are traveling from west to east longitude, so you should name it east. But because longitudes cannot be greater than 180 degrees, you will subtract it from 360 and reverse the direction, because conceptually speaking, that's what the vessel would be doing in this case here. So your answer of Dlong between 160 degrees west and 170 degrees east would be 030 degrees 00 minutes west. Go through the different examples again to get an understanding of how to calculate the Dlong between different longitudes.